Ladies and gentlemen, this is Sarah Pollack for the fourth and last time today. We've had three talks already on embedded systems, embedded security, monitoring of network traffic, IoT, robotics, gaming, virtual reality, augmented reality, and even Plato's Republic and testing of human ethics in VR. It has been a full day, and I'm sure that you're all, your minds have now turned to goulash from all the wonderful information that you've heard. But we have been saving one of the pearls till last. It's a great honor to have Jan Vítek, one of our top scientists ever, to join us for a discussion about programming languages, and also Jindřich Kubát, who's a fantastic capacity from Commerzbank, who'll be talking about the application of programming languages and also that transition from being a startup to being a corporate, what that actually looks like and the nitty-gritty of that. Before I dive in and before Jan takes over with introducing his research group, PRL at Prague, but also his wonderful work that he's done throughout the years. He is a professor of computer science. He has studied all over the world. He's currently hailing us all the way from Switzerland. And he's really done some amazing milestones in terms of core research, whether that's the implementation of the first real-time Java machine, virtual machine, or whether that is really groundbreaking multidisciplinary research in terms of the application of programming languages. We definitely have a lot to learn from him. So he will talk at us for a while now with beautiful Alps behind him. And I then have some questions definitely to ask him because I've heard him talk, and he also made a talk last week, which will be linked in the Together platform now. I urge everyone to watch it because it's an absolute gem. But if you've got any real-time questions, then I also urge you to use this opportunity to ask him IRL. And without further ado, Jan, if you could take it away and tell us a little bit about on the topic of this last talk of COFIT Day 2, which is, if I'm to read it exactly, programming languages. Yes, we came up with a very innovative name. So if you could tell us a little bit about that in your research group, we'd be very honored. Thank you.
Yes, thank you, Sarah. Hello, it's a pleasure to be here. So indeed, I work in programming languages, and what that entails is, to look at the abstractions we use to instruct a computer to do our bidding. And we could say, well, why do you need programming languages? Every computer has machine instruction, just spit out a sequence of those and you'll be fine. Unfortunately, this would be very boring, time-consuming, and we would have to change programs every time we change computers. So what we've been doing for the last 40, 50 years is inventing ever higher level programming languages that allow us to express computational ideas at ever increasing levels of abstraction. And as Sarah mentioned, I've worked in embedded systems with real-time Java. We actually programmed UAVs, little robotic planes. We've designed techniques to ensure that languages like Java would perform in real time. And then we've looked at scripting languages, we looked at JavaScript, and the last few years, my group has been looking at data science, and data science being sort of all the applications of statistics to decision making. This includes machine learning, this includes all of the things people do to get insight out of data. And we've been looking at the languages people use in practice to do that. One of them is the R programming language. While alternatives are Python, and there are sort of more specific alternatives such as TensorFlow from Google. All of these are part of this space where we're working in. And our goal is to understand what are the problems actual data scientists have. So if you take somebody working in a bank or in an insurance company or a biologist, what kind of computations do they want to express? And how can we make it easier for them to express them? And the thing that we're particularly concerned with is the notion of correctness. So we've looked at a lot of data science code, And unfortunately, much of it is incredibly error prone. You know, you sort of change a little bit the format of the output and the computation will proceed. You will get a result, but that result is likely to be off. And how far off from the real thing, nobody knows. And it is actually scary when you think about how many decisions are made on results that are questionable. So, you know, this is sort of the context in which we're working. Myself, I have an appointment at Northeastern University in Boston and at Prague here at FIT. And I have research teams in both places. There's a research team of 7 graduate students doing their PhD in Boston, and in Prague, we're probably 14 at this point. This is funded in the US by the National Science Foundation, the Office of Naval Research, and in Europe, we have the ERC, part of the European Union, and also Czech grants. And we do quite a lot of collaborations with industry. So for instance, about 7 years ago, we collaborated with Oracle to build a faster implementation of the R language, because what Oracle wanted to do was combine data science, data analysis with their database engine. And more specifically, what they had observed is that the typical workload, say in finance, was you had a database with all the financial information, you had a data analysis program, and the data analysis program was sending requests to the database. These were slow, as you had to externalize the data and so on. So what if you could inject your database program inside of the database process and communicate directly? That was the starting point of that effort. And Oracle has adopted our code, and since then I don't know what they did. So industry, pure research with applications that people can relate to is sort of what we like to do. There is a longer version of this discussion and introduction. It's a talk that I recorded called Data Scientists Are Programmers Too. And the talk makes the point that the work that people do on software engineering, programming languages, compiler translates as applications to data science. And I hope that if you're interested, you look at it, and you're free to welcome to ask me questions afterwards by email or here. So that's a very short introduction to what we do, and maybe I'll let you decide where to take this next.
Thank you very much. I have a lot of questions regarding actually the logic of programming languages on its own, and the way that we kind of interact with machines, because it's almost like a chicken and egg thing, that we create a machine that we then create a language to communicate with, and then we adapt the language to the machine, and then it's just a really interesting cycle. And I remember when I was studying linguistic theory at university, I was often wondering how programming languages and the syntax and things like theories of Chomsky or de Saussure, how they actually map onto latest research, and then even areas like natural language processing. In the last talk, we discussed multidisciplinarity and the importance of it in academic research. To what extent do you, for example, refer to linguistic theory or like other disciplines to inform your research in that regard?
Right. So this is a wonderful question, because programming language research has that freedom that even in linguistics you don't have. We can come up with a completely new programming language in maybe a year, and if we're lucky, it gets adopted by millions of people. And so we have that freedom, and there is actually very little in the space of understanding what makes a good programming language. So, while people have studied natural languages, their properties, we tend to invent a set of new abstraction, throw it out there and see if it sticks. And there is, we have some understanding of programming languages as mathematical objects. We have some understanding of them as software artifacts. But once we step outside of our bubble and try to talk to end users, it's much harder. So what we do and what we do in our group is often to take existing languages and analyze how people use them. And that's our way to get feedback. So it's not that we have a model of how to design the right language. It's more like we will look at how languages were used. And for this, it's really lucky that there are platforms like GitHub, where you can get millions of projects and you can do, cross-project analyses that will say, well, this feature that was introduced in 2014 has not been taken up. People don't know how to use it because, well, we've looked at 50 million projects and only 300 used it, or some such. And these kinds of, this is sort of our way to do linguistics, right? We can sort of analyze usage by looking at the body of code. And this is new. This is only the last 10, 15 years that we have the ability to do that. Before, you didn't have access to code. So there isn't yet a proper theory. And I think people like me tend to be more on the technical side, but I think that's a wonderful area for future research to understand, sort of how we could bring in, results from, say, linguistics. It hasn't been done yet, or at least not enough.
That's really interesting. I think you would have loved our previous discussion. I'm going to dare to bring one more theme into it, which is the idea of swarm intelligence, or like hive mind behavior, where I was talking to one of my friends, Tomáš Mikolov, who actually works in the area of natural language processing, or at least used to for quite a while. And we were exploring this online thing called, I think it's called Kaggle, where basically people sort out various problems and you get given a beautifully labeled data set, and it's basically like an ongoing hackathon on like 200 different fronts. And I was wondering, so we have programming languages in terms of their relationship to computers or like specific machines, but then the network or the community of these machines and making sure they communicate with each other effectively, and that it's not just like a one-to-one, but a one-to-many or many-to-many type of communication. Is that also a problem that you're solving, how to effectively communicate in these swarms almost?
So I have looked at it a long time ago during my PhD thesis at some aspect of this. So back in that time, we were interested in finding out if we could have programming languages for mobile agents. The idea was, let's say I can, program these little entities that will act on my behalf. Can I technically move them around the internet? And, my particular research problem at the time was the technical problem of, I have this computation running on computer A, and I want to relocate that computation on computer B. What does that mean for all of its open connection, its environment, all of the technical aspects? And this led to really difficult question in the field of computer security. So we were very naive when we started this. So that was in the early 90s. And then we realized, but if I let programs move around, maybe something bad could happen, perhaps. And then at some point I sort of realized that, this is probably way too complicated for someone like me. And I switched to data science, which sounded much easier.
It's often the case that the best scientists are the most humble ones. So thank you very much.
No, you have to know your limits, and they exist.
Well, speaking of existing limits that I don't think exist in relation to you, but that exist in relation to technology, I was wondering where we draw the line between basically progressing in the area of programming languages, and say that there is a revolution that takes place, but all of the legacy technology, especially at scale, that banks use, healthcare facilities use, like all of these vital institutions for our everyday life, that are going to take years before they revolutionize themselves technologically. How we can basically, like, where the line is between cutting edge research and revolutionizing programming languages, and then actually scaling them and making sure that legacy technologies can be replaced at scale.
That's a big problem. So in the US, for instance, all the pharma they have to keep all of the data analysis code that validated a particular drug for 20 years. And not only do they have to keep that code, they have to be able to reproduce the result down to the last digit of precision. And the practice that I've heard is, the state of the art is each of these companies has a basement where they have actual physical computers. So this is the 99 computer, which has all of our analysis we performed on 99. If you ever want to see those results, we'll plug that machine back in and we'll push the button and it'll run the same way. Now, this is an example of, well, why do they do this? Well, because everything changes. The hardware changes, the operating system changes, the language and the libraries change. And your code will not run the same. It may run, but it will be different. You're pretty much guaranteed of that. So, if you're, so we've been contacted by a big bank in the US. They have this problem. They were somewhat forward-looking. 15 years ago, they picked Python as a programming language from some major projects they have. And they picked this language. They decided Python 2 was the right version. And now 15 years later, that version of the language is being deprecated. They have several million lines of code that are written in that language. And they see that, shortly they will have to do something. The problem is that all of those lines depend on libraries that are 15 years old, and these libraries since have evolved. They don't know exactly how. Python is not a language that has much static error checking. So, if you change code, it will run or won't run, and you don't know until you to try. And so they're stuck. So technology changes. You have to adapt. There's a huge cost to it, right? Why would I adapt? My system is working. I don't want it to do anything else. It's just because everything is changing that I have to invest and pay engineers to just keep the lights on. So one of the things that we're working on, and this is true also in our project on R, is we're looking at ways to help programmers automatically migrate code bases. So the title of our ERC grant is Evolving Language Ecosystems. And the idea is a programming language, you can take it broadly as the language, the libraries, the code you write, maybe the documentation. It's like this big ecosystem. And if you make changes and improvements, it will break, and these breakages will percolate through the layers. What we want to do is try to help people move things without breakage. So figure out where we're going, what is the improvement that will make your code, your algorithms better, and then how can we help out, to migrate that code to there without breaking the whole thing. And this is research. We don't, there are sort of some partial solution, but it's a long-term research program, and one that has a lot of opportunities for PhD research and for transition to industry. So I know there are companies, for instance, that are maintaining systems written in COBOL and Fortran languages from 60 years ago. And their business model is, we will provide the service that we make it run for you. And, they're making good money on that.
Thank you very much. And I actually have a couple more questions for you, but actually, given that there's only 3 of us here, I'd like to make it at this point a little interactive. Jindřich, Jan was just talking about, big institutions and big corporations, when they have a lot of legacy code or legacy technology, that the need to replace it or the need to maintain it. And I'm just curious, from your perspective at Commerzbank, obviously I realize that you can't give us any details, but if you have experience with big internal technological tectonic shifts and how they work, who the stakeholders are, just maybe for the students listening, obviously studying all this is one thing, but then seeing it play out in real life is a whole other Game of Thrones. So if you could maybe give us your perspective, that'd be really helpful. Thank you.
Oh, sure. Hi, everyone. Just we have a name for it. We call it technology debt, of course, and our big zoo in the company. Komerční banka is a big company, big corporations with long history. We have been working with system that's from IBM, that's from the last century. So how it works, of course. No, it's very difficult for the company, especially for the bank company who didn't realize that there are technology companies that these things matter. Yeah, because these companies are usually focused on business, and IT was just something like in the basement, and it works, right? Why should we change that? And now it's more and more how more and more is visible, this technical debt, and how it slows down the whole business. It's crucial for the company to improvise somehow and modernize the systems. It's costly. It's usually to say, well, it's not easy for everyone. We have a lot of, at the moment, at the Komerční banka, we decided just not to modernize step by step, which is plus minus recommended approach. But we realized to do something like a big bang at our company. So we would like to change most of our internal systems. So there will be new core banking system, new front end, and completely new, let's say, middle layer. And we would like to so gradually implement this and gradually switching our customers to the new systems. And so this is how we would like to fight with this technology debt. So we later to decide to focus on this big not project, we don't call it project, but modernization of our systems. And this will be at least for 5 years a minimum project for us.
Thank you very much. Thank you. And we look forward to hearing more in your presentation very shortly. Just before that, maybe a final couple of questions for Jan, and we can have a little discussion at the end. So obviously you're in Switzerland now. You've worked all over the world. In the US, you've got clear ties to the Czech Republic. Czech Republic, especially after the fall of communism, sometimes the mentality in the education system, maybe like until graduation from middle school, can sometimes sadly be quite Austro-Hungarian. I was just at a conference today that actually discussed this, and there's hundreds of very scattered kind of initiatives trying to change that and make the approach more multidisciplinary, more with a global outlook. But it's a work in progress, and the risk-taking mentality that you sometimes see in the West isn't so much happening here, and also the multidisciplinarity of cooperating with industry. Obviously, COFIT is a shining exception, but it's not so regular as it is in the West, including spin-off startups and kind of that bridge between research and applied science. So for our students watching, do you have any tips, maybe any concrete examples from your local research group where you have implemented your kind of great way of working that could inspire them, and how to kind of become more, I guess, global students and global scientists than just focusing on the local ecosystem?
That's a big question.
Yeah, the blueprint for the future of education, basically.
Yeah. So one thing that is sort of that people can do on their own is to look at opportunities to broaden and branch out. So can give the example of one student that I've been working with. It's maybe, when was it? 2008, we had a workshop that we organized in Prague. And this was organized with Charles University, open to local students and students from all over the world. And only a handful of Czechs came. And one of them was a master student from CTU, And he said, oh, this is cool. Can I come work with you? And I was at the time in the US at Purdue University. And I said, sure, come for a PhD. And he came, spent 2 years there. Then for personal reasons, had to come back home. Then he worked for a year in England for Sony. Then I sort of hooked up with him again and convinced him to go when I was going on a sabbatical to Palo Alto. So he came with me to Palo Alto for a year and a half. And now he's been doing a PhD at CTU and is like in the last stages. And, you know, that is like a sequence of coincidence. You go to a workshop, you talk to somebody, you meet there, from what one thing leads to another, leads to another. And I think, you know, this is the way things happen. You know, you have to make a step, take a chance. Sometimes it works out, sometimes it doesn't. But, you know, getting out of your comfort zone is really helpful. So the takeaway here is, you know, there are conferences organized in Prague because foreigners kind of like to go to Prague. You know, it's nice and it has all that history stuff. So, you know, when they are, you know, join. You know, you can volunteer, you can help out with the conference. People need that. And, you know, that's an opportunity to meet people and one thing leads to another. So it doesn't answer the big question, but on a personal basis, you know, as a student, you know, there are steps you can take to become global. And, you know, now things are harder, conferences don't happen. So you have to find other ways to do this. And, you know, like there are some conference on the internet, you can try that, or maybe things will come back, the world will return to sanity, who knows.
You're absolutely right. And it has such bad connotations, networking, but just like human contact and like that butterfly effect of what seemingly seems as chaos, but can actually be point A that leads to you getting a job or changing your life forever, is absolutely true. And because I studied in the UK, and that was a big part of the university education, to learn how to network and to go to these meetings, go to recruitment events where you basically just went for the free drinks and the free food. Sorry, obviously only the free food. You never drink at university. But yeah, and things like COFIT are fantastic in this regard. But I often heard it even when I engage in various popularization activities when, oh, why are you going to this event? Because you can't measure a KPI from it. It's like, well, you can't measure a KPI from it, but you will meet 20 people and one of them may be useful. Like you never know. But I've seen a big change in mentality here compared to the West. And I think that is the last piece of the puzzle that would help us kind of get forward. So if you're watching this, don't be shy, ask questions, network. There's nothing bad or sleazy about it. It's just like a way of collecting information around your surroundings and making a better path in life, a more informed path. And I see that someone has already taken that piece of advice because we have a question for you, Jan. It's from Michal Dvořák, who says, and I quote, it's a bit of a longer question, so I'll just read the whole thing. A question for Professor Vítek. You've mentioned the quality/success of a newly created programming language is discussed mainly in the terms of how well it is accepted by the community. Are there cases in which a programming language is designed as a contract, i.e., and he says he's making this up as an example, a game dev team wishes to include a scripting language within their engine? Is it common that the team consults with a specialist which tailors a programming language to the team's needs? So basically, like, does it have to be accepted by the community, or can it just be designed because it's fulfilling a contract or a very specific need?
So yes, that's a really cool question. There's three kinds of languages historically. There are languages that have come about because somebody had a problem, an itch that they couldn't quite scratch with existing technology, and they developed their own language for it. So C, C++, you know, were those itch languages. Then there are cases where it's, you know, a company. And these people, the people who do these each languages can be random folks. They don't need to be computer scientists. They can be statistician. They can be mathematician, anything. And sometimes companies decide they want a language, and that could be Java or Swift these days is popular. And what's the question was touching on is, are there cases where, you sort of have a language and somebody comes and says, oh, I need it, it a little bit different. One thing that comes to mind is, so Facebook, it's a company in the US, and it does software. And for some reason, it picked PHP as their programming language. And PHP, so in my community, there are two languages people laugh at. One is R, which I work on, and one is PHP, which Facebook picked. And they laugh at them because they're really bad languages, people will say. Well, maybe not. This is, I'm no judge on quality here. But so they had PHP. And one engineer at Facebook, a young French guy, Julien Verlaguet, decided, now PHP won't cut it. We need to do a better language. But on the other hand, we're stuck with, by now, 20 million lines of PHP code. So what to do? So he invented a new language that was like PHP, but sort of better. It had types and things. And very gradually, like the story of the frog being boiled, they started introducing the language and teaching programmers to use it. The language they have now is called Hack. And, and Hack started to become slowly, the majority of the code, more and more of the code was converted to Hack. And the way they sold it to programmers was they said, well, if you use Hack, you will have an IDE that will help you write code faster. And that was true. They actually did the effort of creating an IDE that was much better than the one they had for PHP. So this was a case where, you had this language that existed and somebody said, well, there should be a better one. So this was done internally as like a side project from a very sort of enthusiastic and excited guy. And it was just adopted organically. The company said, oh yeah, let's give it a try. And now it's used, by everyone at Facebook.
Thank you very much. That was a great answer, and I hope, Michal Dvořák, that that satisfied your itch in terms of the question. If you have more questions, please feel free to put them into the Together chat. We have a unique opportunity to chat with Jan and Jindřich. Jan, thank you very much. Please, if you have the time, please do stay with us on the line. I'm sure there'll be some more questions that pop up. And now I would like to move swiftly to Jindřich, because I'm sure that you will have, I really like the theme of your of your presentation, from startup to corporate, because as someone who's been in both corporate and startup, and sometimes seen the smoke and mirrors in both, it's really interesting to see that transition in mentality, the way that technology is applied, but then also the day-to-day reality when all of that falls on your head as an employee, how to deal with it, how to function, and how to organize so that the whole system carries on working. So thank you very much for being with us, and I very much look forward to your presentation.
Mm-hmm. So hello, everyone. Again, from my side, also a pleasure to be with you. My name is Jindřich Kubát, and I have prepared some short talk about DevOps as a, let's say, modern process and processes, how to develop and maintain software in production. So instead of programming languages, I will talk about human beings named developer, and about the responsibility of this developer in the modern era of companies. I also prepare some few slides for you, so let me share it. So I hope that you can see it. Okay, yeah, you can. Great. So I'd like to talk about and share my experience from startup to corporate, because I have been working in all of the companies. So firstly, I will start something about me. Okay. So at the moment, I've been working as a head of development in Komerční banka, which means that I'm mostly manager at the moment, leading about 700 people. And I have been working then for 2 years. Before then, I started my career as a developer, PHP developer, by the way, and I really like the language. I started my career in a very small company that they didn't call startup by this date, but it was literally, we were working from garage or from basement, and it was 10 people there. Then after 2 years, I moved to a mid-sized company, let's say, internet mall, and this company grew up rapidly. Yeah, from the, we were started and from 10 people in the development to more than 100 in next 10 years. And then now I've been working as a manager in the Komerční banka. So one of the biggest challenge for companies is how to really run software, how to develop it, what will be the processes, because it's very, very costly, especially for big companies. And related to this, it's a very modern processes behind the word DevOps. And I'd like to talk about this and share some of my experience. So what's DevOps and how it started? Well, in 2007, it all started with frustrant Belgian, Patrick Dubois, which was hired by Belgian government, migration, some government data. And after 1 year, he were talking about a big inefficiency in the traditional process in the development and operations, and big wall between these two departments. Then, 2008, a great agile conference about agile infrastructure. It wasn't not DevOps yet, but in 2009, a really, really great conference from John Olspo and Paul Hammond about how that Flickr did 10 deployments per day. It was something big, that's before it was pretty common to do 1 deployment per month, maybe 3, few deployments per year in big companies. And now Flickr, why the hell we should do 10 deployments per day? But it makes a lot of sense, for a lot of companies. So it started a huge adoption in the US. And then a great book about DevOps and processes, the Phoenix project from Jim Kim. And now we can see everyday DevOps research report that it's trying to cover a lot of thousands of companies and how DevOps is adopted in these companies. So this is a short talk about a history of DevOps and how it's related to Agile. But I'm sorry, I have my slides in Czech because I have been told to do this in Czech, but I hope it doesn't matter. So agility, I also think that you are also familiar with the Agile, and the agility is primarily focusing on the cooperation between business and development department. Yeah. And that means that prioritization is better. You can communicate with your client directly. Yeah, you can't hide behind some processes and so on. But the agile itself and the agile movement just realized we just forgot on one big department, which is operations, that works in the basement, and there's a big wall. So how to improve the efficiency of the whole process? And then, well, I think that the DevOps emerged on the scene. So DevOps is also culture, I have to say, because DevOps is not just that we combine development operations, and it's not that developers will have direct access to the production. It means that continuous improvement in our work and how to do, let's say, our work more smoother. And it's a combination of two things from my point of view: time to market and availability. Yeah, how to get these two things all together. So one quote from Jim Kim: the DevOps and its resulting technical, architectural, and cultural practices represents and convergence. Sorry, I don't have my slides. I can't read it. But in my words, it means that the DevOps is not just that the developer will have access to the production and this quote, you code it, you run it. It's all true, but behind this is a never-ending path to how to increase our flexibility and productivity alongside availability on the production. And there's a lot of movements in the industry, and it gets the best from all of these movements, like Toyota production system, resilience engineering, and so on. So now about the purpose of this presentation, how it works in the startup. Well, for many startups, sky is the limit. On the other hand, as a developer, you need to have a big range of your professional experience, from the developer to the administrator to the technical writer. You literally have to do almost anything. It's great. I mean, for many people, you can get a lot of experience from these areas. In the startups, there's almost no regulations, no processes, but also there's no free time. Yeah, you have to literally work almost every day, every 3 minutes in startups. So in most of the time, a developer is an administrator. That you build it, you run it, means that, okay, you are fully responsible for your code. You are responsible for emergency. If something breaks, it's usually don't have the big impact on your customer if you have customers. But you will learn how to write a good software from my point of view. Yeah, it was a big school for me. And I got a lot of good experience from this, from startups. Okay, about the mid-sized companies. Okay, now I think that it can be combination of the best or the worst from both worlds, meaning that mid-sized companies like Internet Mall is a big-sized company, mid-sized company. You can see a lot of automation there, but on the other hand, I saw a security was really underestimated. This is also applied for the startups, of course. I also realized that founder has always truth, meaning that when we are trying to deploy something to the production on Friday night, because we do DevOps, right? It should be everything automated, and we really mess up something. A founder called me that, hey, why did you did this deployment? Why you didn't deploy over the weekend? So we are trying to convince that this is not the way, because, you know, we are trying to really automate the process of the deployment, so anyone can do deployment anytime. And this is the purpose of the DevOps, main purpose, to deploy code safely to the production. I also see some in this mid-sized company that try to copy some corporate processes or methodology of the development. And, you know, it really depends. Something it's fine because finally it has some order in the processes, but on many times big corporations has a big technology debt, really rigid processes. And if you would like to succeed on the markets today, you have to be flexible and flexible react on the situation on the market. So in that cases, a time to market is something very crucial. And with 3 deployments per year, that's probably not for you. And of course, in these companies, if you are very good, it's pretty easy to be a star in this company if your boss is not total asshole. So my advice for you, when you look for a job, for your first job, just really be sure who's your boss and who will be your team, and what will be the processes in the company. It really matters on your future career. And last but not least, corporation, how it works in the corporations. Money on the first place, right? Many big corporations are very crucial for state, like a bank, of course. So these companies are regulated by strong processes, by a regulator. They have a big enterprise systems. So if you really want to touch something big, with impact to the customers, impact to the state, and so on, I think that these enterprise system and corporations are for you. You will meet with hundreds or maybe thousands of people in IT, and they are usually willing to help. It also really matters. I think it's also a good starting point in your career, because it's very crucial if you have something around you who will help you with to understand how to do the software and other things around the development. So I see a big potential for transformation in big corporations, because now they are realized that they can't survive on the market when they do 3 or maybe a few releases per year. So at the moment, there's an agilization, I call it agilization or DevOpsization in these companies. There's a huge potential for these companies to improve their systems, and also you can get a lot of experience from this transformation. And last point, from time to time, in these corporations are working not nice people. So I really recommend this book, Defense. So if you want to survive in these companies, sometimes it's necessary to be on top of this, what is happening in these companies. Well, a last slide about us at KB. Of course, that's we are still hiring. Most of our development is written in Java and .NET. And recently, I opened a new position for PHP. There's a lot of great opportunity to start career as a test engineer or auditor and so on. So just please visit the link if you are interested or would like to get some experience. Also, you can join in our next workshop in Thursday, I believe. And if you want to leave some contact, just use the QR code. So that's all from my side.
Thank you very much, Jindřich, and thank you for the freshness. Freshness is a really hip hop word, but like the freshness that you provided, because I think that COVID has shown that we're all just people and we're all just trying to function somehow, and that a lot of the things that have been happening in companies are not sometimes optimal, and they're just a thing of habit rather than being a thing of logic. So you've shown us a very pragmatic, flexible view, and thank you for that. What I'm actually wondering about is, I've got two questions. The first one is about startups. And of course, startups, as you quite rightly pointed out, are not always profitable, mainly because they're reliant, they've got a great idea, every startup is going to change the world, and they're very reliant on investors. So sometimes, actually, paradoxically, or at least I've experienced this, they can be more toxic than the corporates, because in the corporates, they're so big that people like lose sight. But sometimes when the investor says it's got to be like this because I'm giving you my money, and the investor doesn't understand the technology that sits underneath it, they just understand the vision. It can be much more of a police state than the corporates. What's your perception of that, and how do you think it affects deployment and of technology and the development of technology?
Yeah, well, very good question. Thank you for it. Well, from my point of view, if you have a really great idea, just do it. Yeah, just try and really try it. I think when you are young and you have no family, nothing too lost, I think it's great to start your own company. Of course, there's many traps. And especially from the potential investors. So if, the problem of this world is that there's a lot of free money at the moment. And you can find a lot of investors that would like to, invest in your company, which is great. But it also, in many cases, means that you will completely lost everything in the end. Yeah. So just to be very, very careful what kind of investor you would like to share your company, but it is fact that only I think 1% of all of the startups will survive this early phase, let's say. But anyway, you can get a lot of experience to run your business or join a startup company, of course.
Thank you. And actually, I have a follow-up question from that, because a lot of the times when you create a startup, you're a bunch of friends or someone that you really trust, or like in a lot of cases, like a visionary who often comes from the humanities, and they've got a big idea, but they have no idea how to actually make it happen. And they have a friend who's a great techie, and they say, oh, come aboard, come help me. And then that person becomes integral, like either as a CTO or like head of product for the entire thing. And then the startup becomes successful, it becomes a unicorn, whatever that means in this day and age. And the product starts snowballing and snowballing and snowballing. And then you get into a situation like Facebook, where you have suddenly a huge corporate employing tens of thousands of people that started off as a pet project, used to rank girls at university. And a lot of the engineering decisions you already can't really take back, because they're in the heart of the product, buried under layers and layers of decisions and years of development. Is that a problem? And like, how would you, like with everything that we know about the startup world, how would you prevent that from happening as much as possible?
Well,
so sorry again, like I ask big questions, I'm sorry.
I know. I think that you must have a big luck, of course, in your life to meet good people. You must have a really great combination of skills, not just just a techie skills, but you need to really sell your visions to others and build your team. And you alone just can't do anything. You need to build a great team, and this is the main, let's say, purpose of the founders, the initial founders of every company. And then, you know, you must have a big luck for your first investor, and so on. So it's really hard to you know, give you some advice what to avoid. It's always about the team, about the combination of skills and luck for your people and first investor. That's from my point of view.
Thank you. And then similarly, how does it work in big companies when we want to do like internal spin-offs? So say you have a group of people that are very, very talented and they're working on a very particular problem, and they have a good team, they go for a beer with each other, and they want to almost create like an internal working group or a working almost startup. Again, like, do you have any tips from practice or from what you've experienced that is a healthy way to approach that? Also from a management perspective, that you basically have this outlier group that is doing their own thing within a larger animal. Is that becoming more frequent, and is it maybe becoming easier to do during COVID?
Well, you know, in corporations that I have experience with KB, which is not so big corporations from my point of view, there are much bigger corporations in the world like SG, you know, Facebook, Google, and other companies. Maybe sometimes you can hear that, yeah, go to the corporations, you will get a lot of money and you can hide, you know, yourself. It's not easy. Yeah, every single person in the corporation, at least in the KB, is under some, you know, we are really closely looking at what the people is doing. It helps, you know, not by just some software or something, or from the management point of view, but we later started with the decentralization of work. So we created a small units, and every single unit has its own product owner, and it's for teams, it's very visible if you are doing something or not. And if you would like to do something very new, you must have support of your product owner or your manager who will, you know, finance your idea. And it really depends. But it's also it's possible, of course, when you have a great idea to do something, especially in the agile. Your management is much closer to you than before with you know, traditional software delivery processes. So that's my answer.
Thank you.
Yeah.
Thank you very much. And I would like to bring Jan back with his Swiss Alps, if he's still here. Yes, he is.
Yes.
This once happened to me. I was with my mum and granny, who always bring me food because they think that I need like nourishment 24/7. And I was at a conference, and I was pretending to be very like, you know, and then my granny brought me fruit dumplings, and as I had this one huge dumpling in my mouth, they suddenly called me up to answer a question. So that was a lot of fun. But Jan is of course a professional with a fantastic T-shirt. Also,
yeah, I thought we should endorse our commercial partners.
Definitely.
This is old. It used to matter. Now people don't care anymore. It's funny. Microsoft was evil. Intel was evil. Now it's all water under some bridge. But I like the T-shirt. Anyway.
Very good T-shirt. And I actually wanted to ask. We've been just discussing with Jindřich the different modes of basically moving forward applied technology in commercial settings, whether that's a big corporate or a startup. You mentioned like hive mind problem solving in terms of research. Do you find a similar approach, maybe like with smaller research groups or bigger kind of academic institutions that have been around and have like a much bigger PR and like a different, maybe bigger structure? Maybe for the students as well, because they plan on whether that's traveling through Erasmus or trying out various research groups. how to navigate these different types of research groups and research environments, and whether that has an impact on the way that you approach problem solving.
Yeah, so I'll pick perhaps a slightly different question, which is, if you had to pick where you want to go for your research, what would what are the criteria you would use to decide? Which is not exactly what you were asking, but I think it's related, and I think useful for students, right? So often you say, well, should I go to a top university, a big research group? Should I study an area that is currently in popular? All of these are very valid questions. So you could say, well, now machine learning is all the rage, so I should definitely be a machine learning expert. And MIT is the best university in the world, possibly, so I should definitely go to MIT. And there's this professor that has published 150 papers, therefore I should go with them to study. And yeah, this is great. But one, you won't get there. Two, even if you would get there, you'd probably be miserable. And what is popular today may not be popular in 20 years, right? So how many thousands of machine learning experts do we need? So all of this sort of goes towards the answer that you should be realistic. You should look for people, not places. You will be collaborating with an individual. And one of the good things nowadays is everybody has switched to remote presentation. So you can meet, quote unquote, your professors before even approaching them. You can look at their talks. And, it's not perfect, but it does give you this idea, is this a person I would like to interact with? So going for, say, a PhD or a master's is a commitment for a master's 2 years. For a PhD, I don't know, mine was 9 years. So you better be sure that you're going to enjoy this, that you're going to get interactions. Then the second thing you do if you want to go somewhere is, of course, you can contact a professor and you'll find out something, but much better it's contacting the students in the group, right? You sort of send an email and say, hey, I just want to chat, I'm thinking of coming, and you'd be surprised. Most people will say, yes, sure, I'll chat. And in the chat, you say, how is it to work there? And one of the questions that I've heard is there somebody who failed out of the group? And if they have long stories about that tells you something. Then another thing you can do is check, does the professors publish with students? Some very famous professor publish with other very famous professors. You say, well, why are the students there? Well, because they need to spend the money. Why do they need to spend the money? Because it's a status symbol to get grant money. It doesn't matter what you do with it. So you need to spend it. So you burn it on students that you never meet and never talk to. So, all of these things are sort of there. You have to navigate those. So in industry, it's, picking what company I want to work with, which job I get. In academia, it's picking which university I will join and what professor I will work with. But, in both cases, there are good and bad choices. And surprisingly, there is information in both cases you can have if you work at it to make an informed decision. When my students go to industry, the biggest sort of thing I warn them is boredom. Boredom will be your enemy. You won't be fired. You won't be living under a bridge. You will have a job. But chances are that 2 years from now, if I call you randomly and ask you, how do you feel? You'll say bored, because I'm doing the same thing, because I'm good at it. And, I'll be doing the same thing in 10 years. So then people change company. But the key is, can I find a job that will be more interesting, not boring? So one other way to think about this is, for me, it's always important do I get to make my own mistakes or do I live with somebody else's? This was the technical debt that was just mentioned earlier, right? So technical debt is you live with the screw-ups of others and you have to try to make them, look nice. In research, you are always making our own mistakes because we're always doing something new. In startups, the first 2 years, you're making your own mistakes and then you live with somebody else's. So.
Thank you very much. Yes, that's boredom is, I think, the worst thing for a mind. And I've been talking. It's amazing the human brain, how it constantly needs to be distracted somehow, without people realizing. And I have a friend who was doing photography for an unnamed company, and he was doing like 1,000 photographs of and basically people treated the photography sessions like a bit of a psychotherapy session, and they basically came to him and they said, I'm so bored, I'm so unhappy, and they're like, oh, how long have you been here? It's like 10 years. It's like 10 years, why? So it's an interesting thing when you put that onto research groups as well, that it's important to choose well. And I have a follow-up on that to Jindřich. Jindřich, you are full of life, energy, and freshness. And you mentioned the importance of money when making some of these decisions. And I remember some of my tech friends from the startup that have been offered like various positions. And I used to be like, my first contact with tech was actually as a headhunter for Palantir Technologies. And I remember the people wanted to work on solving problems and making the world a better place. And you'd say, to start talking about money, and they'd be like, oh no, I don't care. I want to work on interesting stuff. And then sometimes it would actually make a difference for them, like what programming language you use. And they'd say, oh no, I'm not interested in that. I want to solve problems, but not that way, like Python's shit. So it was a really, really interesting learning curve for me. How do you keep these types of people occupied so that they don't get bored, but also don't get frustrated from doing inefficient work that is just trying to artificially entertain them by basically doing sprints about stuff that doesn't matter, or inviting them to team building exercises that nobody wants to go to? What do you think is a constructive way of keeping, say, fantastic students of Jan not entertained in a company, but to keep them psychologically stimulated whilst simultaneously fulfilling the business needs? And again, big question, but just curious about your opinion.
I need to think about it for a while, because in all of the companies, you have to solve real problems. That is, and these problems are usually comes from the customers. So you need to kind of switch off your mindset that you will help the world, that everyone will be happy and so on. And you need to find your happiness in that you solve real life problems of your customers, and you need to live with your company. And it's also very, very important for the corporations. You still need to live life of your company, the purpose of the company, why it's on the market, how it serves your customer. And from my point of view, this really helps you to have this fresh mind and to have this reason why you are doing what you are doing. Yeah. And that's no matter no matter what kind of company you are working for, if a corporation or startup, you just need to find a reason for yourself, and you need to be stay with the company's purpose.
Thank you. So it's building a sense of community and actually reacting to the real problems in the real world, and not just like an abstract vision or like being like a hamster in a wheel. Yeah.
Yes, exactly.
And community, actually, the notion of community, and don't worry, gentlemen, I know that we've already been here over an hour that I've been grilling you. So I've got one more question for Jan, and then a common question for the two of you, and then I will let you get on with your life so that I don't hold you here much longer. From Karolina Hrnčířková for Jan. Again, I will read this verbatim. It starts off similarly to the previous question. I've got a question for Professor Vítek. When creating a programming language, you mentioned that the community's acceptance is one of the main factors to measure its success. How important for the language's success is how easy/adaptable it is to changes, and how hard is the code's translation to machine code? And for me, something like Esperanto comes to mind. When you desperately try to create a universal language, you sometimes fail miserably. So what are your thoughts on that? And thank you, Karolina, for asking.
So success is often unrelated to the technical aspects, right? So whether the language is well designed, whether it's easy to modify, or whether it runs fast. Often they're more about, does the language solve a problem? And that's a difficult question, right? So for instance, R or PHP are, I still claim, not well designed in some sense, but in another sense, they solve actual problems that people needed solving. And this is why PHP exploded, why R is used 25 years after it was created. So you can make a language that is better, but adoption remains, an incredibly difficult challenge. So I've worked on one new language with IBM. So as a researcher and contractor for IBM, we were designing a scripting language that was to be something like a mix between Java and JavaScript. And, the language just died. It never went anywhere. So it's and why did it die? Technically, it was not a bad design. It was a very nice design. It was better than, or at least in some aspects, better than the previous languages, but it didn't take, and the company pulled the resources. So often it takes. So the languages that succeed often are the simple languages, or they start simple. So things like JavaScript started very simple, Lua started very simple. And these are languages you can do as a single individual. And if you're lucky, if stars align, you're solving a real problem, it can take off. There's no good answer. So if you don't have the resource of a large company, you have to design something small, and you have to design something that is easy to change, because you know that you will have to change it yourself many, many times. Yeah.
Thank you. It actually brings the evolutionary work of Richard Dawkins. I'm not his greatest fan in some respects, but he did write a book on memetics in 1976, and it was about the transfer of ideas and the way that the human brain is adapted in terms of absorbing certain basically components and symbolic ideas, and some not. So it's just interesting if something hits that sweet spot, I guess, as well with the community, or the community starts using it ironically, that it's such a complicated language that actually only a few of the chosen ones can use it, and then it becomes mainstream because it becomes cool. It's really interesting.
Coolness is an important factor too.
Yeah. Do you have an example of a language that maybe started off like this, or that has a weird backstory, or that where coolness, for example, plays a part?
So I think coolness is often a matter of what programmers think is exciting. So for instance, the language Scala was picked up by programmers who liked functional programming, this particular kind of programming languages, but wanted to be more practical than some of the previous languages that existed. Now, a language named Rust that was created by Mozilla is becoming popular because it is this it's a researchy language, yet it allows you to write code that runs as fast as C. So that is very efficient. And that's it combined this coolness because it uses a very complex mathematical type system, yet it lets you do something that are really programmer think, oh, that's really hardcore programming. So there is some amount of, coolness factor there. And yeah, so people pick up these languages for various reasons in the programming field. Now, when you talk about, you know, less sophisticated users, like people who do web pages or data scientists, they will try to pick the simplest language that they can get their hands on that does the job, right? They don't have all these pretensions, oh, we're really little mathematicians hiding inside. No, they just want to get something done, and they will pick the language that has the best libraries and that, you know, gets them to the place they want to go without having to become a computer scientist.
Yeah. Very cool. Thank you. Yeah, Scala. I remember the hype. That was a lot of fun. Great. Well, I have the last question for you both. It's going to be the same question for the both of you. Actually, one of the reasons we're also doing this COFIT in English is to attract a wider range of students, also from abroad or English-speaking students, but also to be able to translate the Czech talent abroad. And I don't want this to sound like cheesily patriotic. I just want to, because I do see like a lack of confidence sometimes in our ecosystem that is existent, for example, in the West, both in the applied commercial industry area, but also in research. So maybe, Jindřich, just to start with you, what do you think that, given what we've discussed today, Czechs are really good at, like world-class good, and that we should be proud of, and that the students, when they apply to go abroad or when they come back from abroad back to the Czech Republic and they think, oh, do I want to come back? That they can come back because there's a vibrant system here and a lot of talent. So maybe something motivational for the students for the end of the day, that would be great.
Well, you know, I think that's we all grew up in the Czech Republic, and it's great country. You know, when you compare it in the many countries in the West, at least from my point of view, you know, I met with many people that just returned back from US or UK or other countries. And it's still just, they told me that they always call them back, you know, back to the Czech Republic. I think that you can get a great experience. Of course, you know, that's the life abroad is completely different. But I think that's, yeah, Czech Republic is a great and many people from the in IT. And I really hope that Czech Republic will one day will be a technology company, you know, one of the top technology company, and not just that we do cars, you know, in here. And if I just may a few more words about the programming languages, something you know, in my mind. I think that, you know, it really depends what kind of software you would like to write in the programming languages. It was very popular in the past to write, you know, big monolithic applications, and languages like Java, .NET, or so on are great. Problem with these languages are they are too big now. You know, that's you can learn some basics, but usually in the companies, they are using some kind of framework, and you need to learn this framework. And this is for years to learn something to write something big. And now these big applications, big monolithic applications, I think that's they are almost on the end of their life. And a decentralization, you know, you can see it everywhere, even the software. So the microservices are now leads the world, and new languages around the microservices are now on the top of the scale. So from my point of view, I really love Golang, for example. It's a very young language. You can't see any object of OOP programming paradigm there, but it's still very great language from my point of view for writing microservices. So it also depends what kind of system you would like to write.
Thank you very much. Everything from decentralization to coming back home. It was a very positive message. So thank you. And thank you for being here with us today, Jindřich. Jan, how about you? You've traveled all over the world, been pretty much everywhere, researched pretty much everything. What is your opinion on the Czech ecosystem and something that we've got to be proud of?
So I actually know the Czech ecosystem less. So one thing that I was impressed by when I started working at CTU was that how friendly the environment was, and both welcoming, because, you know, coming from abroad, I, you know, didn't know anybody really, and I needed to start a group from scratch. Hire students, find students, you know, postdocs, programmers. And I think that it would have been hard to find an as nice group of people anywhere else. So, you know, maybe I was lucky, or, you know, there is something to that. In terms of quality of people, I think, you know, there's, you know, talent, you know, there's plenty of talent. So, and quality of life, you know, that. So here's an anecdote that I find amusing. So, I came from Boston, and before coming to Boston, to Prague, I had a postdoc that joined my group in Boston, and this was a fellow from New Zealand. So, really tall fellow, almost 2 meters tall, but he's Chinese originally. So a Chinese Kiwi in Boston, and he followed me to Prague. So in Prague, and after a year of working in the group, he realized he liked Prague so much that he would apply for a research position at Oracle Research in Prague. And it's been like 4 years now, and he's been at Oracle. And as far as I hear, he's a very happy camper. So there is something to this country.
Thank you. Well, there you have it, ladies and gentlemen. If we can attract a Chinese Kiwi living in Boston, now working at Oracle, then we can achieve anything. So this has been a really almost like a clubhouse discussion, but it's been a very nice human way to end the day. And Jan, Jindřich, thank you again. I know that there was only 3 of us, so you were exposed to a lot of intense questions from me, but I really appreciate it. And I also really appreciate the engagement of the public. Ladies and gentlemen, to you watching on the Together platform, this is the end of today. Just to summarize what we've done on COFIT so far. So the first day we went through the future of IT and artificial intelligence and why the hell we're cooperating with industry in the first place. We then went on to image processing and talking about the limitations and also the various new machine learning methods that are being deployed in that area. And then we ended off the day with the computing, big data, HPC, GPU, and parallel and distributed systems, and even spoke about the future of quantum computing. So it's been visionary from start to finish. Then on Tuesday, today, we've kicked off with a very simple, easy, kind of chill out topic of embedded security and ethical hacking. We spoke about TrueCrypt, access management, but also making sure that embedded systems are actually secure, because there's still plenty of threats that can happen there. We then moved on to the monitoring of network traffic, IoT, robotics, smart lawnmowers. You can see that we were truly multidisciplinary. Moving on in terms of multidisciplinarity, we did computer graphics, gaming, VR, augmented reality. We spoke with the 2 great gentlemen from the Together platform who are making all of this happen in the virtual world. And spoke about the bridge between humans and technology, because it's that symbiosis that's going to determine our future as a society that is undoubtedly changing. We are on the verge of chaos slightly. Things are changing. COVID has changed a lot of things. And AI and tech isn't a silver bullet, but only with being human-centric and cooperating with humans can we actually make the world a better place, not to sound extremely cheesy. But we've even spoke about replicating Plato's Republic in VR. So we were truly multidisciplinary. And then finally, I had the great honor of talking about this Python's Flying Circus, of discussing programming languages with Professor Jan Vítek, as well as Jindřich Kubát from Komerční banka, talking about which programming languages catch on, which don't, the whole logic and philosophy of how we talk to machines and how they talk back, and also the research and industry ecosystem in the Czech Republic and beyond, and how we can be a global nation and a global ecosystem. To those of you watching, thank you very much. It was a great day. We have another day tomorrow. So the festival is almost over, but you still have a wonderful piece of content in front of you. So tomorrow, 10 o'clock again, we've got a managerial informatics, where we'll be talking about how the hell to manage all this, and how to combine business savviness with actually making it technologically happen. We'll then be continuing at 1 o'clock with web applications and large software systems. And finally, my personal, sorry, not that I'm backing a horse in this race, but we've got machine learning and artificial intelligence, and we've got 8 speakers. Wow. Yeah, I'm going to try my best to keep that to an hour and a half, but we'll make it happen. That's at 4 o'clock. And afterwards at 8 o'clock tomorrow evening, we have the after party with a pub quiz and a clubhouse discussion. So we've got a lot of cool stuff prepared for you. Check the website, check our social media, have a great evening, network, go to Slack, network with the HR departments, and enjoy it, because you are the new generation building the future, and you really got to grasp it properly, because if you won't, then someone else will. So study well, enjoy all the content that's being thrown out, have a good rest, have a good dinner, and see you tomorrow at 10 o'clock. Bye. And thank you, gentlemen, again for being here with us.
Bye.